Hello class, we had a question about number 10 from 6.3 and this one has a lot of stuff going on, so I'm going to try to go through it step by step here. So I had to do some of the calculations ahead of time just so we could save some time on the video. So in this problem they're measuring 1 liter milk cartons. They measured a total of 120 of them, and here were the corresponding volumes. So there ended up being 6 that had this volume, 18 that had this volume, and so on and so forth. Okay? So if we want to find, first off, the sample mean, we're going to have to take the frequency and multiply it by the volume. Okay? And then add that by 18 times 0.99. Plus, we're going to go all the way through, multiply all of these frequencies by all of the volumes. Okay, so this is just a little simpler than adding 6.98s, then adding 18.99s, just save a little bit of time. So doing our calculation this way, we're able to calculate a sample mean of 1.01 liters, which starting off is good for the company because we want our sample to be at least at that 1 liter benchmark value. Okay, so we are asked also to calculate a standard deviation for this. Now, since there are 120 1 liter cartons of milk that we're looking at here, this could be an incredibly tedious calculation if we had to do all of them individually. So we'll try to simplify that calculation a little bit here. So we're going to start off just like in that previous example, by taking our volume and subtracting our sample mean from it. Okay, so 0.98 minus 1.01 is negative 0.03. We'll keep that going. So 0.99 minus 1.01, negative 0.02. So if you keep that going throughout, and then we're going to square it because that's part of our formula as well. Okay, so x minus x bar squared. And then we're going to have to add all of these up. But it's not as straightforward as that because we're not just doing it one time, we have to do it the right number of times. So this volume came up 6 times, so it's going to be 6 times this value, plus 18 times this value, plus 30 times this value, all the way to the end here. So if we make this big long calculation here, and again, since it's a sample formula, we're subtracting 1 from our sample size, so 120 minus 1. Remember, 120 was the total number of 1 liter bottles. That leaves us with a standard deviation of 0.0148 liters. Okay, so it looks from the company's perspective that if we have an average of 1.01 and a standard deviation of 0.0148, that's going to mean the majority of the 1 liter cartons are going to be at least 1 liter, but not all. Okay. In B, it's asking, is this a sample or a population? So in this problem, we aren't given every measurement in the entire facility for every 1 liter carton that they make. It's only a portion of them, so that means it has to be a sample, and we're going to use the sample formula. In C, they're asking about 2 standard deviations above and below the mean. So if I subtract 2 of our standard deviations, and if I add 2 of the standard deviations, that would mean that acceptable containers have to be between 0.9804 and 1.0396 liters. I think it was asking, is a bottle that has 0.98 liters in it going to be accepted? Well, if we're going to this many decimal places, the 0.98 would not be accepted because it's a little bit outside of the range of values. Okay. Lastly, they're saying another day there was a sample mean of 1.012, and we have a sample standard deviation of 0.009. How does this compare to these calculations here. So first off, you'll see that our sample mean is a little bit higher and our standard deviation is a little bit smaller. So I think the company would be happy with this, because if we have a higher standard deviation, or sorry, a smaller standard deviation and a higher mean, then that means we're going to have more acceptable 1 liter cartons of milk. Okay, so it'll be less likely to have a carton that is below 1 liter. All right, a lot of stuff going on here. Again, ask some questions. I tried to go through it a little quickly, but if you're not understanding why I had to multiply by the frequency, it was just to kind of save some time, because we would have to do 120 different calculations if we didn't group them ahead of time. All right, thank you. Bye.